Good day to all. Here, We Learners Note is an online solution to encourage an effective way of education to all of your students. My name is Sarika VS and I am your physics teacher. Here, we are going to discuss about the image formation by convex lens. Before going to the topic in detail, we have to know what is a lens. Lens is an optical instrument made up of with glass or plastic type materials, and it will be having two surfaces joined together. If both of the surfaces are in curved form, they are known as convex lenses or concave lenses. In the case of lenses, at least one of the surface should be in curved form. Here we are going to discuss about the image formation by convex lenses. Okay. Before going into detail, we have to know the working principle of the convex lens also. The working principle of convex lens is refraction. Okay, so you can see in this picture, that is, this pencil is inserted in this water, and here you can see that the image of this pencil is shifted. Okay, and the size also increased. This is due to the condition of refraction. So, what is refraction? Refraction is the process of bending of light rays when they enters from one medium to another medium of different densities. That is, if light is enters from air to water, its medium property will be changes. So, the speed of light will be changes. So, this light rays will bends. This is the condition of refraction. This is actually happen here. The same process will be happens in the case of lenses. That is, when light rays enters into lens, it will bends and they will converge at a particular point. And at the point of converging, they will form the image of the object from this light rays are coming. Okay. Then next, what is the advantage or what are the uses of lenses? We can see that the size of the object that we are viewing through this lens can be increased. Okay, we can see an object in a larger size or smaller size than that of the original size, or we can see the same object at further distance or very close to us by using a lens. Okay, this type of properties, that is whether the image or the object is seeing in a larger size or in smaller size or closer or further away from the object, is depends upon their position, that is the position of the object from the lenses. Okay, for that we can see here there is a different conditions, that is 6 conditions are given here. That is, depending upon the position of an object, the position of the images will be at different points, and depending upon that, the relative size and the nature of the images will be different. Okay, so before going into detail, we have to know the construction or the structure of a convex lens. This is the structure. This is a convex lens. We can see that both the surfaces are outward curved. Okay, then we can see that there is a point F on both the sides, and this F indicates the focal points and focus points. Okay, and this C indicates the center of curvature of the each of these curves. Okay, we have 2 focal points or 2 focus points and 2 center of curvatures. Okay, and depending upon the position of the object from this lens, the image will be formed at different points on the other side of this lens. That we can see in this table. Okay, that is, for example, if we are placing an object at 2f1, if we are placing an object at 2f1, the image will be formed at 2f2. Here you can see that there are 2 f values, that is 2 focus points. We can write this focus point as f1 and this as f2. Based on that, this can be represented as c1 and this as c2. And we can see that this c1, the distance of this c1 from the optical center, this is our optical center. Okay, and distance between this optical center and c1 is represented as 2 times of f1. Like that, the distance between this optical center and C2 is 2 times of f2. Okay, so for example, if you are placing an object at this C1, that is at 2f1, the image will be formed at C2, that is at C2. Okay, that is depending upon the position of the object, the image formation, that is the size of the image and the position of the image and the nature of the image will be depend. So based on the position of the object from this lens, the nature, the position and the size of the image will be different. Okay, so we can say that if an object is placed at 2f1, the image will be formed at 2f2 itself and it will be having the same size as that of the object. So based on the position of the object from the lens, we have 6 cases. Let's discuss that. That is, if the object is placed at infinity, the position of the image, that is image will be formed at f2. Okay, and the size of the image will be highly diminished. It will be in point size form. Okay, and the nature of the image will be in real and inverted form. It will be in real and inverted form. If the position of the object is beyond 2f1, the position of the image will be in between f2 and 2f2. And the nature of this image will be in diminished and real inverted form. And in the next case, if the object is at 2f1, the position of the object image will be at 2f2 and the size of the image will be same as that of the object and it will be real and inverted. In the next case, if the object is at focus point f1, the image will be formed at infinity and the size, it will be infinitely large. It will be highly enlarged form and it will be in real and inverted form. Okay, then in the last case, if we are placing the object in between f1 and optical center O, what will be happen? The image will be formed on the same side of the lens as that of the object. Okay, then the size will be enlarged one, but the nature of the image will be different from these cases. That is, the image will be virtual and erect. Okay, so in this portion, in this discussion, we have discussed the image formation by convex lens. Then this is the ray diagrams of the 6 cases that I have discussed now. Okay, here you can see that the image is formed at different points depending upon the position of the object from this lens. Okay, so as a conclusion, we can say that a convex lens converges all the light rays and it forms an image. It may be larger size or smaller size, or its nature can be inverted or in a erect condition. So our convex lens is a converging lens and it works based on the principle of refraction. That is, it works based on the condition of bending of light rays when it travels from one medium to another medium. Okay, dear students, I hope all of you understood what I have discussed now. And we have a lot of videos relating to our topics in our official website, that is www.learnersnote.com. Here I am Sarika VS, your physics teacher, signing off. Here I am going to do an activity to demonstrate the image formation by convex lenses. Here we have 2 types of convex lenses. This lens is having larger aperture and this one is having smaller aperture. Here I am using this smaller aperture lens. Okay, so here we have an image forming screen. Here we have an object. This candle is taken as the object and this is the convex lens and it will be having a focal length of 20 centimeter and this is the lens holder and this is the screen. Okay, then if I am placing this convex lens in this holder and if I am placing the object at 2f1, that is, if the focal length of this convex lens is 20, 2f1 will be equal to at 40 centimeter. Okay, so this is placed here. This is at a distance, that is our object, that is this candle is at a distance 40 from this convex lens. So we can see the image of this candle in this screen, and by observing that we can see that the size of the image is same as that of the object, and it is in inverted form. So we can see that this image is a real one. And if we are considering the another case, that is if we are changing the position of this object, that is if we are placing the candle beyond 2f1, the position of the image and the nature of the image formed will be different. Okay, and again if we are changing the position of object in between 2f1 and f, the same change can be seen on the screen, that is the nature and the size of the image is also changes. So we can see depending upon the position of the object, the nature and the size of the image is changes. Then discuss the other conditions, that is if we are placing the object beyond 2f1, the nature of the image will be diminished one and it will be real and inverted. We can see the same case here. Okay, that is if I am changing the position, that is beyond 2f1, the image form is different, that is it will be a diminished one and its nature will be real and inverted. Like that, if I am changing the position of the object, that is if I am placing the object in between f1 and 2f1, the position of the image will be at beyond 2f2 and it will be enlarged one. Okay, that is if I am placing this object in between this condition, that is in between f1 and 2f1, the size of the image is enlarged condition and it is real and inverted condition. Let's discuss the other cases, that is if we are placing an object beyond 2f1, the position of the object will be between f2 and 2f2, that is if I am placing the object beyond f1, that is if I am placing the object beyond 2f1, that is here, and the object image will be formed in between f2 and 2f2, and we can see that the image formed is in diminished form and it is in real and inverted condition. Okay, then in the next case, that is if the object is placed between this f1 and 2f1, the image will be formed beyond 2f2. Okay, that is if I am placing the object between f1 and 2f1, the image will be formed beyond 2f2 and we can see that the size of the image is enlarged one, that is if I am placing the object in between 2f1 and f1, the image will be formed beyond 2f2 and we can see that the image formed is enlarged one and it is real and invert type. As a conclusion, we can see that the nature of our convex lens is converging. That is, in our activities, we could see that the image formed by this convex lens based on their position of the object varies. That is, the nature and the characteristics of the images formed by this convex lens varies depending upon the position of the object. Dear students, I hope all of you understood what I have discussed on today. Here we have implemented a new method, that is learn by doing. We have a lot of videos relating to our topics in our official website www.learnersnote.com. Here Sarika, your physics teacher, signing off.